Okay, let's start to have a look at step 3 questions. So the first one I'm choosing to look at is 2021 step 3 question 2, which is quite a algebra heavy question. So at times I would have an excuse to not do the algebra because I trust that you all could do the algebra properly. But okay, anyhow, so part 1. Let x equals a over b minus c, and y equals b over c minus a, and z equals to c over a minus b, blah blah so on, right? Blah blah so on. Because by symmetry, okay, essentially, it's quite nice, right? It's symmetrical. Okay, show that that matrix multiplication equals to 0 0 0. Okay, how do we do that? Well, just by doing it, right? Essentially, just plus xc. Oh, and you just prove it, right? So, I mean, what could I do? You chuck in the numbers properly, right? So a minus, a over b minus c, plus times b, by the way, plus a over b minus c, c equals to 0, and then you just factorize, right? It becomes a minus a factorized b minus c over b minus c, right? And that is trivial. Okay. By the way, when you show something, please don't start with the equation. That's a really bad habit from me. Yeah. Start without the 0, please. Okay. Do this. Equals to 0. All right. Cool. And the same for y and z, right? This is symmetrical. Okay. And use the result to deduce that this has to be minus 1. Okay. How will we do that? Well, you just think about this. Where do you see these things? Well, you see it in trinomial expansions, right? You see it in trinomial expansions. What do I mean? I mean this, right? You see it in these things, don't you? Yeah, don't you? And then you could just and so on, right? And etc. And you use what you know from the first part, right? A minus xb minus plus xc, that equals to 0. Okay, that would help with the simplification a lot. That would. Okay. All right. Next bit then. Hence, show that a squared over b minus c squared plus and so on. Okay, it's symmetrical again. It's greater or equal to 2. Okay. So what is going on here? What sort of ideas have I got? So basically, I'm saying, well, this is x squared essentially. This is y squared. This is a z squared, right? Essentially. I mean, it's sort of the same trinomial idea, I think. It's sort of the same trinomial idea. Because now you know that this equals to minus 1. Right? If you know that equals to minus 1, then, well, you just consider this. This is greater or equal to 0. Okay, well, then you sort of do things, right? X squared plus y squared plus z squared. And then, I know that's 2 lots of yz plus zx plus xy. That's greater or equal to 0. Well, I know that's minus 1, right? I know that's minus 1. And then that's QED, right? That's QED. Okay, so the first part is quite sure, right? But part 2 is the main bit, right? It's always the case for step questions. It gets harder and harder. Okay, now part 2. Let x equals to 2a. Okay, let me scroll down. And okay, so there's essentially a 2 in front, and the pluses become minuses. Okay, well, I mean the other way around. The minuses become pluses. Okay? Alright, using a suitable matrix, show that xyz plus yz plus zx plus zy plus xy equals to 4. Okay, you could choose a sensible matrix, right? So let's go for something like, well, what should we do? Well, we have 2's in front, so it might be sensible to, again, observe what you did before, right? Here, like, I now have a 2 here, so it might be sensible to put some 2's here as well, right? So, you want the matrix to have 2's in it. And I think the structure of the matrix is probably the same for the rest, I suppose, from looking at it right now. Okay, the 2 has to be here, minus z and z here. Okay, I suppose this works, but do let me know if it doesn't. Right? ABC probably equals to 4. Probably, okay? It looks like that. Alright, I'm not 100% sure, but if you validate that, you should get 4. Okay? No, not this is 4. Like this. Prove this first, and then show. Right? Just like how you did in part 1. Okay? Alright, hence show that this is true. Okay, what does that mean? this 2a plus b plus c, what even are these things, right? What even are these things? What does it look like, let's say? Well, this is what? Let me divide b plus c here. Let me divide b plus c here. Let me divide the c plus a here. And let me also divide the a plus b here. What are these things? Tell me, what are these things? This is just what? X plus 1, y plus 1, z plus 1, right? Z plus 1. And I want to show that it's greater than 5. Okay, isn't that also trivial? Because this one is 4, right? And from the ones here that you get the 1, you decide. Okay, maybe I should do it properly, just to illustrate what I mean. So x squared plus x plus y plus a 1, okay? And this is z plus 1, that's greater than 5. All good? Now expand further, x squared, okay, what am I doing? X squared, no, okay. Wake up, come on. Alright, so plus xz plus yz plus z plus xy plus x plus y plus 1. It's greater than 5. Okay, I suppose you're showing things, right? So don't write the greater of 5 yet, okay? Again, that's a really bad habit from me. Okay, and what do I know this thing is? Look. This, what do I know that is? 4, right? 4. Has to be 4. Right? And there's a 1 here, so I could put 5. And what do I know about x, y, and z? Look back at the question. They're all positive quantities, right? Because I know that a, b, c are positive real numbers, and I'm adding them, and I'm dividing them. There's no way that I'm going to get anything negative. Yeah, no way at all. So, I know this is positive, so this is strictly greater than 5, QED. As required. Yeah? Okay. Show further that this is greater than 7 times this time. Okay, essentially I want to change this number to 7, right? Okay, so what is my proof? I have to prove, if I write this in an alternative form, I need to prove that x plus y plus z is greater than 2. That's essentially what I'm trying to do, right? I want to prove it greater than 2. Okay, let's have a look. Let's do this in terms of A's, B's, and C's, because I think it makes life slightly easier. What does this mean? This means that I want to prove, how do I do this? 2a over b plus c plus 2b over a plus c plus 2c over, a plus b is greater than 2. Okay, so the, what is it called? The 2 could be get rid of. Yeah? Okay, now, you see now on the top, you have a plus b and plus c, sort of. Right, you have like a, b, and c, sort of. But in the denominators, you have the pairwise sum. Which is slightly annoying because it doesn't cancel properly, right? It doesn't cancel properly. Now, how can I make it such that it cancels properly, though? How can I make it such that it cancels properly? Now, what if I do something like this? What if I did, let's say, a over a plus b plus c, for example. Or I did, let's say, something like b over a plus b plus c, and c over a plus b plus c. What do you think that does? What is this quantity, by the way? This quantity is just 1 itself, right? Just 1. We know that equals to 1. So, if I were to get rid of this a to make the original, that proves to me that the original is bigger than this. The original is bigger, right? Because the denominators are all smaller. Because I know that a, b, c are all positive. So now I've proved that if I get rid of, these things that I don't like, this has to be greater than 1, no matter what. I.e., I've proved my original statement, x plus y plus z equal greater than 2. which means that 5 plus x plus y plus z is indeed greater than 7, which means that, if you chuck into ABC form, then this is shown. This is shown. Yeah? This is a really pretty question, I think. Although it's really algebra heavy. I didn't quite do all the algebra, because that's your job to write it properly in the exam. But you see, that's how we think about questions, right? There's lots of logical deductions going on, right? I think it's quite a good question in terms of, I don't see, it's quite clever to use a matrix to show these things. That's the beautiful thing about the question, I think. Although there's not much matrix and vectors things involved in this question, it's quite brute forcey as well. It's probably a manageable question, I suppose. It's probably a good choice as well. Yeah. Although it might be slightly boring, but still, yeah.